Imagine a photographer pulling out an old-fashioned 4x5 field camera, like something that your great-grandparents' wedding photographer would have used. But this one is fabricated out of fun and fruity-colored 3D printed plastic, laser-cut panels, and scavenged optics. Archaic technologies and a traditional approach to visual arts are being revisited and revitalized thanks to 21st century fabrication techniques.
Welcome to Augmented Humanity. Our guests are modern explorers working at the intersection of technology and the humanities. They help us to understand ourselves and the worlds we create in this digital age. They are thinkers, creators, makers, and academics working in diverse fields like linguistics, technology, game and object design, and ethics.
I'm your host, Ellen Dornan.
And I'm your host, Craig Goldsmith. We're joined on this program by Ethan Moses. Ethan is a maker, designer, and fabricator specializing in some of the oldest forms of chemical photography. He utilizes state-of-the-art digital fabrication techniques like 3D printing and laser cutting to create cameras based on old designs and expired patents. He is a regular contributor to online magazines and blogs about chemical photography like Emulsive, Film Shooters Collective, and 35mm Collective. He teaches chemical photography techniques online and at makerspaces. Ethan is also a member of the board of directors of Quelab, a makerspace in Albuquerque. His company, Cameradactyl, makes 3D printed film cameras and accessories for the general public.
Welcome, Ethan. Thanks for being on today.
Hey, thanks for having me on.
I kind of wanted to start looking back at the history of photography. Earlier today, you showed me some 1910 era technology that you've re-envisioned through the magic of 3D printing. Going back, what did early photography look like?
What do you mean, like all film photography at this point is like kind of early photography, right? It was,
it's all archaic.
Yeah, on the scale of man, it was like a blip between when they went from the invention of photography of tarnishing silver plates through a pinhole or something like that to today where we have digital.
Let's talk about two of the cameras that you make, the 4x5 field camera and the pinhole camera. So when were they first used? How do they work?
Pinhole cameras date back to the camera obscura, which I think the Greeks and the Romans, maybe the Chinese knew about thousands of years ago. The introduction of photosensitive paper or plates kind of really made photography take off.
Just so we're clear what we're talking about, a camera obscura or a pinhole camera is a box with a pinhole in it.
Yeah.
Okay.
Yeah.
The light goes through the pinhole and then kind of projects on the back wall of the container.
Yeah, exactly. The pinhole is just sort of a geometric limitation you can give the light to make it focus some sort of clear image.
Then photography really is the ability to capture that image.
Yeah, exactly.
So it's really putting these two things together, the optics, and then you've got something that is light sensitive so you can capture that image. And the first photography happened sort of when?
Let's say a little bit before the Civil War, so 1830s is when people start making like wet plates and things. Before that, people definitely had success on like little silver plates and daguerreotypes, and Henry Fox Talbot made some salt prints and paper prints a little bit later. But yeah, it became common in Western culture to have photographers around by the 1860s.
And for you, why the paper photography? Is this what we call it now? Is chemical
analog photography?
Analog photography.
Yeah.
And what do you find compelling about that as a process rather than just shooting with a digital SLR or a cell phone?
Well, so I do both. I do all three for sure. But I don't know. I had a lot of film. This is less philosophical, but I had a lot of film left over from the days when I bought and sold cameras, and I thought I'd work through it. I like building things a lot, and there's some digital camera projects that I'm working on, but it might take me 10 years and only cost $3 million for a camera that you could buy for $800.
What's the appeal for the people in your community?
So the appeal is different for a lot of different people, and I try not to be one of these guys who like has the sharpest lens or like the most recent whatever, but I'm also not one of these guys who's like, I use the oldest process, I wax my mustache, and I'm shining silver plates every day. I think there's everybody in between, and the reasons are far-reaching and varied. For me, again, I don't think I've done so much introspection as to put my finger on what the magic of film is.
Well, here's your chance.
Yeah, right. I don't know. I really enjoy it. I really enjoy like old mechanical devices. I enjoy that I can build them. And film does all of the work of your digital camera in a product you can buy.
Right.
You know?
Do you like the darkroom process also? Is that part of it? Because building the camera and taking a picture in these old ways is one thing, but then there's all the post-processing.
Yeah, darkroom work is fun. I don't think it's like the number one reason why I do it. Sometimes I'll send my film out if I'm busy, but it's an interesting part of the process. I really like teaching the darkroom processes to people. It's kind of like magic when people first discover it, usually. It's a very sort of simple thing to show somebody in 20, 30 minutes.
I'm curious to what extent you favor the output of your film cameras, and especially some of the cameras that you're building, because I know looking at the examples online of, say, from your pinhole camera, they do have a very otherworldly, old-fashioned-y, I mean, even like the picture of you pitching your tent looked like it was from a Civil War campaign.
Sure. I generally just build pinholes as demos. Like the cameras that I really love to build take what I would call modern optics, right? They take lenses from professional film cameras from the 40s through the 2000s. And so one of the most interesting things to me when I first started 3D printing cameras is that it's basically just a black box, right? And the pictures will look like whatever lens you put on it. And you could go to eBay and buy all of these great old lenses for peanuts to a lot of money, depending upon what you found. I don't know, the otherworldly pinhole stuff, this is not my art. Right? I like shooting with them. They're fun sometimes. As for output, like the things I like kind of look like digital pictures by the time you're done.
I don't know about that. I mean, I only say this because when I saw you recently down at one of the makerspaces, you had crafted a 8x10 paper camera out of laser cut panels, and you were developing prints, and the portraits that I saw didn't look like any digital photograph I've seen. Well, I mean, maybe if you ran a bunch of filters on it.
So one, digital is getting better every day. Apple AI is incredible. They're not quite there, but yeah, so what you saw was actually a bunch of prototypes that I've been working on. But basically, this actually might be interesting to you. I'm going to go on a tangent right here. Do you guys know about the 20x24 Polaroid?
The large format Polaroids? Yeah, that's exactly. A darling of the art world for decades, and then the film stopped being made.
Yeah. And then Super Sense started cutting it up into 4x5s and selling it to people for $10 a picture, one by one, which is interesting, but there's not very much media left, right? Well, so Polaroid made this thing. They made 7 of them from the late 70s to the early 80s. And it was just sort of like a loss leader advertising thing, you know, let Andy Warhol shoot a 20x24 picture or whatever. It's good advertising.
There are people that may be listening to this that don't actually even know what a Polaroid is.
Polaroids are almost instant film and paper packs that you take a picture onto and then eject through some rollers, which smush some chemical dye between the paper and the negative, and then it self-develops. You know, in about a minute and a half, you have a instant picture
without a darkroom. So the 20x24 Polaroids became difficult to get a hold of, and was actually a really big deal. I remember when that happened, when they stopped making it, and all the artists were freaking out.
Yeah, particularly Elsa Dorfman, known for using that camera. I'm a really big fan of her work. So I've been sort of thinking about and working on this process to, I don't know about replace, but replicate that sort of thing, right? I can make 1 or 2 of these as an advertising thing for Cameradactyl, and maybe a few for some crazy customers who want a 6-foot-long camera. But I've been working on direct black and white positive reversal prints, or direct color reversal prints. You can shoot a picture on regular print paper. So if you were to go to Walgreens in the 1990s and get your negatives printed onto 4x5 paper, that paper is basically the film emulsion wiped onto or sprayed onto a piece of paper rather than a clear plastic base. And so when you print the negative by projecting light through it onto the paper and expose the paper to the negative image, it makes a negative of a negative, which is a positive. And so because of this property of photo paper that it has a photographic emulsion sprayed on it, you can put it directly in a camera, any camera, that you can cut a piece of paper small enough to put it in. It's a little bit slower and has some limitations, but traditionally what people would do is take that photo paper, develop it, get a negative, and then either rephotograph it or contact print it, which is sandwich it with a new sheet of paper and then project light through the old negative and then develop that and get a positive. So this is sort of like a long and arduous process, but I've been working on a process by which you develop a piece of paper shot in exactly the same way inside of a camera, but when you develop it's, one shot, it's a positive. And I've made some YouTube videos. I'm not going to get into the, chemical reversal process, but if you want, it's a 5.5 minute video to show one of them and maybe 10 for the other. What I want to do now is build a film holder or a paper holder that is also a developing tank. So basically you could shoot a picture on a piece of paper with a large format camera, pull the film holder out of the back of the camera, tip it on its side, and then pour in some chemistry. Now, it's maybe not as elegant as squishing gel packs of chemistry in this giant 20x24 Polaroid, but I think it's something you could do without a darkroom, and that produces a print in 5 to 10 minutes, depending upon the process.
It's very quick chemical photography developing, and you could do it in the field or on your tabletop without a darkroom, like we used to do with Polaroids.
And if you build a big enough camera, you can make really big prints, like a 20x24 or even larger.
So it begs the question, aside from the love of the process and the challenge, which I, as a maker myself, I certainly get, what is it that's compelling about this sort of technique or process that isn't offered by, say, modern digital photography?
Yeah, so it makes a really unique looking thing. If you're using the black and white process, generally you're using orthochromatic film, which is only sensitive to, let's say, the blue spectrum of light. And so things like reds show up as black. For example, my red beard shows up as a black beard, but it also makes people look very ruddy, which is useful sometimes and not useful others. Also, being shot on a giant camera has a really shallow depth of field, which is very challenging to work with, but also, if you do it right, sometimes is very beautiful. The color process has some wacky results, again, some which I like, some which I don't like. None are extremely like digital cameras or even smaller film cameras. A 20x24 camera is maybe going to be 6 feet long. I'm not going to carry it around on a neck strap. I'd probably use it for some project. I'd try and take a portrait of every one of all of my friends and then put the thing away or ship it to somebody. But there's some aspect to it that's almost performative. I'm not exactly a performer, but people love interacting with that sort of camera. And for what reasons, which is really your question. But for me, it's nice to sort of show people that moment when, you take a print out of a tray and then you pour a chemical on it and it goes from white to having a color photo on it, or from a negative to a positive, depending upon the process. People are into it, but also I think it lays bare the processes of photography so people can really see what's going on in any camera, right? But it's at a more human scale and time frame.
I think there's something really crucial there. And I've seen this where you've shown a few of your cameras and had people kind of interact with them, and then you can see the process and you can understand the process. A little kid can actually understand, whereas with a digital camera, really is just a magic black box. But what you said I thought was really interesting about photography almost as a social dynamic. It's been a long time since I've seen people crowd around a camera because the camera itself becomes this sort of object of interest, and the taking of the picture becomes a really kind of intense interaction.
Yeah, I think good photography shows you things that you don't see every day, and that's really not just photography. It's like new and weird things are interesting. It hasn't been around. We were in 1950. I don't think people would take so much notice of a film camera, but it's something you don't see every day. And I think that's a good teaching tool. And I think it's a good sales tool, because ultimately at the end of the day, I'm trying to sell all these things on the internet.
Right. You said something there also really interesting. You said it shows you something new about the world, about ourselves.
Well, good photos to me is something that you don't see every day. And that could be because it's taboo, because it's far away, because it's taken in a dangerous place. place because it's something rare going on, because it's an extinct animal or a previously thought extinct animal. Right? These would be all interesting pictures that I would look at. I don't usually get to take those pictures. When I lived in New York, I just carried a camera everywhere because I was guaranteed to be surprised by something on the street. That's what I love most about photography, which has nothing to do with whether it's shot on a, Nikon D8, I don't care what camera, if it's an interesting photo, and which is sort of maybe not what you would expect to hear from a guy who sits around making cameras all day. I love making cameras, but and I love making cameras that I like to shoot with, but yeah, I feel like my love of pictures is almost very separate.
Well, but that's sort of what brought you into it to begin with, which I think is probably a nice place to leave off this segment. You're listening to Augmented Humanity. We'll be back in just a minute. Welcome back to Augmented Humanity. Ethan, you use expired patents for creating some of your cameras?
Yeah, so sometimes it's really interesting now what you can do with the internet, right? So I don't know that in 1995, when everybody shot film, I would be able to make film cameras. I certainly wouldn't have had access to things like $200 3D printers that can make almost any shape I want, or laser cutters, or makerspaces. One of the really interesting things is Google patents. So if you want to know how something works, you could find a repair manual somewhere, pay for it, ship it, go to the Library of Congress, look for its patent, or buy it and take it apart. But oftentimes, if you're just looking at like the most base piece of a mechanism and trying to figure out how a shutter works, you can look up all of the patents from 1935 or 1918, 1950. And the interesting part about making mechanical things is we sort of reached mechanical supremacy a really long time ago, before we went to electromechanical everything. Since the 70s or 80s, everything has had digital solutions, or if not analog, electronic solutions. And for the most part right now, digital solutions for things like light metering, film metering. And so if you are trying to look for mechanical geared solutions for one sort of thing or another, Google Patents has all these expired public domain patents for different types of wind mechanisms and shutter mechanisms and that sort of thing. Of course, that's not like a formula on how to build such a thing or how to even design one, but it gives you the base idea of how such a mechanism works, which is a great starting place.
So I've never researched patents, and I'm very curious about this. You know the equipment, so you know specifically what you would be looking for. So, for example, with the film rewind mechanism that you showed me in your camera, you said it was 1910 era technology. So you knew you wanted a rewind device, and you went and found patents for it. And then what kind of information do those patents contain?
I'll give you a two-part answer. So I'm not always looking for a patent for a film rewind device. Sometimes I'm looking for a set of intermittent motion gearing, which, in clock design, there's maybe 1,000-year history of these sort of designs. So the patents I'm searching for are wide-ranging and mechanical, if I am curious about a thing. As for reading patents, there are patents of different types. Could I read a chemistry patent? Probably not with such proficiency as one that's a set of gears and how they work. But generally, they will do a pretty excellent isometric and orthographic projection view of the thing and maybe some cut sections, just hand drawings usually. And then they might label all of those pieces. And then they will, in the first part of the patent, make a claim about what this thing does. For example, they'll say what the the problem is that needs to be solved, what the current state of the art of solving that problem is, and what this patent does to improve. So you might see something like a shutter dampener on a Leica camera that's just a patent for this little like rubber or spring stop. And so it would say, currently cameras suffer from this amount of shake and noise due to this type of shutter. The state of the art shutters are built like this, but they don't have this bump stop. And then they would go on to say, this bump stop decreases the sound of the shutter by X%. And then they would go on to describe the motion of the shutter and how this bump stop acts on it. A good patent will lead you through the steps of each piece of a machine from the input to the output. It's very like step-by-step Lego's approach to actual mechanical systems.
So it's a diagram and then an explanation. It's almost like a how-to video. Well, in the case of what you're looking at, these mechanical objects. I just also want to back up just a second. Something that's come up with a lot of our guests, it seems like over and over, is the democratization of knowledge, the democratization of technology, the democratization of fabrication in the modern era. Google patents is actually something I have not even heard about till you had brought it up, and I spend way too much time in the land of the Google overlords. So what is Google patents?
Probably you and a bunch of your listeners would be familiar with things like Google Scholar or Google Books. Generally, that started out as paper information and maybe is now hard drive information, but should be cloud information available to all, yada, yada. I'm not going to get into digital data politics, but the point... The point is that it's a repository for lots and lots of scanned information.
So it's an archive.
Yeah.
This is only expired material or not copyrighted or...
You know, I am not 100% sure on what they are scanning and what they're scanning and not publishing yet, but a patent is a public document, right? So generally when you patent something, you don't want to give away the goose. You want to protect your mechanism, but not necessarily show how your mechanism is built. But there's a lot of patents on Google patents, particularly American patents, particularly, electromechanical patents pre-1970s, but even through, modern patents are up there.
And they have metadata and stuff, so you can sort of punch in useful searches and turn up. But then you're looking at kind of scanned documents in that sense.
Yeah, but I think they use a lot of OCR. So while it's scanned, it's still pretty searchable. Google's pretty good at that.
I want to sort of revisit that democratization of fabrication. And I know that you're active in a community of people who make their own cameras. Do you find useful information from what other people are researching and learning? Do people share information or share findings in any way?
Oh, yeah. This is actually kind of interesting, is that there are certain processes that maybe wouldn't have been done during the film era that are now done because, one, there are no commercially available options, and two, that there are forums like Fotrio and APUG, Facebook groups, right? Everything has kind of taken off because you can share information with weirdos super interested in what you're interested in their corner of the world, right? Like there's not 10 people on my block who really like hanging out and building cameras. I'm that one weirdo on my block. And so, the internet really brings people together, which is incredibly interesting to me, particularly if you're interested in some real small niche. The other part of it is sort of like back and forth and community aspects of these things. It's often a dilemma for me, right? Because the power in what I do is, at least theoretically, that I could send a file to a dude in China and he could print it out for, less money in materials than it would cost me just to pay for the shipping to ship him a camera. But often I don't do this because I'm not famous enough or charming enough to make money doing something like, YouTube. I've seen other creators use these sorts of methods, but at scale, to give away files like this. But figuring out a way to profitably share files and designs with people so that they can make their own and modify it would be really interesting to me, because there are other bigger projects that I would like to work on that at my small manufacturing scale, it really doesn't make sense for me to make. So like film developing machines, I have 12, 13 3D printers in my house. The parts are cheap. At least the electronics are more sophisticated than you would have had in a photoprocessor in 1995, and they're dirt cheap, and you can buy motors for $7 from China now. You can buy motor controllers for $1.50, power supplies for $2. These are things that I don't think I could manufacture, but absolutely, make a list of parts that you could buy on AliExpress for $30 and send out a set of STL files for the physical pieces that you need to print, and then make a YouTube video on how to put it together. It would allow people for $250 to build a Noritsu, which is $50,000 machine now, and also rebuild their Noritsu after Noritsu and Fuji go out of business making these types of things that you can't now get parts for. And so would it be as good as a Noritsu and perfect? Maybe not, but I think it would do a really good job. I think it's not rocket science. And after that's done, right, it would still require that people build these things at home, maintain them at home, but it would require a bunch of people sort of ponying up a lot of cash to just make the design files. And I'm not sure if the internet's willing to pay for just a set of files, right, or at large pay for it. So then I would give it to everyone for free, right? There's free rider problems with that.
A what problem?
A free rider problem?
Free rider?
Yeah, or
I haven't heard that term.
The tragedy of the commons. In the economically rational man, there's some impetus to not pay for a common good if you don't have to, and then nobody pays for it. I think there's also perception problems. The open source ethos, you just get things for free. I really appreciate that. I stand on the shoulders of giants. It would be really interesting if people could put full-time work into open source projects. I think that is the real thing holding the 3D printing camera revolution back, is that there's probably 100 people that I know who could do just as good a job as me if they just quit their jobs.
So I just want to touch on one last thing before we close this segment. The whole Google patent thing, I think, there's something really so critical there in terms of being able to access the existing storehouse of knowledge. You talked about something called mechanical supremacy, that everything's already been solved, it seems like. I run into this with my own projects. I used to be a much more reinvent the wheel kind of guy, and then I smartened up, and now I'm much more likely to get online and see how someone else solved it. So I'm curious, are you patenting or copywriting any of your own work?
I'm very small and niche, right? And so I probably could afford the money to patent a few of my designs, although my designs are really about the execution and how they're put together, right? I have come up with a couple novel mechanisms that allow me to replicate the motions of older mechanisms with less precise manufacturing techniques. But, my market is niche. I don't have a ton of money. I wouldn't have the money to enforce any patent violations, nor would I want to. The way I sort of have intellectual property rights is I just don't give out the STLs most of the time, right? It's a sad thing to do, right? I have so much, sort of personal pride to see my stuff getting used elsewhere, whether, I send it to somebody or even if they make it, right? So I had a project a while ago. I made a shutter timer. I needed a tool to calibrate a shutter, right? So it measures the duration of time that a shutter is open in microseconds or milliseconds. And these are traditionally pretty expensive tools, although they've just come down in price to $150, $200. But I built one for $4. And it's a pretty niche tool. And I didn't think that by the time I paid for FCC testing, for electromagnetic compliance, and got a bunch of these things manufactured, I didn't think I would be that much cheaper than the $150 one. And that was a pretty good one. And maybe I would sell 100 of them. So I just said, okay, here's a freebie to the world. And I made, a GitHub page for it where you can download the code. And I made a YouTube video on how to assemble and use it. I'm not a YouTube star, but 3,500 people have watched it or something to date. And every month or two, I see some post up Instagram or Facebook where somebody has made one in Egypt, somebody has made one in France. It's pretty cool to watch things like that have legs.
That is really cool. But yeah. I know that you write in your blog about the difficulty of creating economic models for walking that line between sharing the information, having your cameras in use, and giving people a way to get that hands-on joy themselves. So I know I've been experimenting with kits or things like that, but it is true, once you put the information out there, it's just going to be duplicated and shared all over the world. You have no control.
Yeah, but I love it, right? That's the power, right? The question I think that all the creatives have is how do you monetize the thing I want to give away for free so that everybody has it? I don't know. I don't know that I have the answer. I got a degree degree in economics. I don't know. I don't really know anything about it.
And on that note, we will end this segment. You're listening to Augmented Humanity. We'll be back in just a minute. Welcome back to Augmented Humanity. Ethan, we've talked in our previous segments about the fabrication and design of these old technologies as new objects in the 21st century for taking light and capturing it onto paper or film. You've been trolling Google patents for old patents that you can look at to develop the mechanisms for these kinds of things, and you've put a huge amount of personal time into developing STLs, which are 3D printable models for the parts. You know, there's a huge growth in the last 10 or 15 years in what's called the open source movement, where you make designs and code freely available to others. We were talking how you could send someone a design file for one of your cameras where they could print it at a library if they don't have their own 3D printer or at home for so much cheaper than it would cost you even to ship one of your cameras. But is there a path forward beyond being a tiny manufacturer? It used to be that you might hire an artisan to do what I would almost think of as small-scale manufacturing, and you would pay that person a lot of money to build one thing or two things or three things. It was very custom, or it had a very high quality. Now with these newer fabrication techniques, we have a thing where it's customizable, but it's not custom. And the technique itself is meant to be easy and, like you've talked about, not necessarily super high tolerance. So where's the path forward for an economic model that lets people that have all these clever ideas and make a living beyond, say, teaching, which is the first thing that came to mind?
It's a long way to ask a question that I spend a lot of time thinking about, and is maybe not the first obvious question of what do you think about when you want to make cameras. But if you want to make cameras 24/7, 365 days a year, you better think about this problem. Or if anybody who makes anything probably is thinking about this problem. And I think there are many paths forward. Some will surely lead to dead ends, maybe dependent upon how they're managed or maybe not. You know, the classic examples, I think, of people doing things like this. So when I grow up, I would love to be Simone Yetch. She's like a real inspiration to me. She's a YouTuber. She's pretty famous, like way more than me. But she was the queen of robots, and she would make these YouTube videos.
Oh, I know her. She made the robot that hits her in the head, the rubber hand that hits her in the head. She's brilliant.
She's super funny. And she actually just did a Wired article where she was sort of talking about not really wanting to do that anymore. But I think that her
she's done hitting herself in that.
To take herself more seriously. And,
right.
And she was talking about sort of being a younger woman that people don't necessarily take seriously, and a lot of her projects, or even the naming herself the Queen of robots is a little self-deprecating, and then stupid people will look at that and be like, yeah, she's dumb, but if you pay attention, she's one of the most brilliant people on the internet. And her model was to be funny and likable and do these projects, and really, like, it didn't matter if the projects worked or not. It was the video about the project that were always excellent. And I think then that has sort of branched out into her selling products like the Everyday Calendar. To me, at least, because for a long time now, she has put out excellent content and continues to do so. I think that's success. I don't think that's the way for me. I used to say I wanted to be rich and not famous, and I used to be halfway there, and now I'm going on all these podcasts and ruining my advantage. I would just like to make cameras and have money fall from heaven.
It's called a grant.
Right, yeah, but then you're writing grants. I gotta write some grants for Quelab soon, right? Or you got to go on YouTube and sell YouTube ads around the entertainment video around the building of the project, or the how-to video around building the project. However you slice it, you better be spending some time that's not building cameras, that's thinking about and doing those things that it takes, right? And so I've been running like a very traditional store up until this point, where I just make a thing and ship it to somebody.
And it sounds like you're actually talking about 3 different activities. So one is the R&D, the researching the patents and figuring out what kind of components you want in a given camera and designing the camera. 2 is actually manufacturing the camera. And 3 is putting together the documentation or the marketing products to let
that's
people
what we're
know
doing today.
How to use the cameras, or how to assemble the kits, or what have you. So you've done a Kickstarter, a successful Kickstarter for one of your cameras, right? I mean, is that a good model for covering the R&D aspect?
I don't know if Kickstarter is a good way to monetize only the R&D, right? The last time I ran one, it was pretty successful, but I don't know how you classify it as like a donation and then a thank you gift, whatever. But like ultimately people were buying a physical product, right? And I'm asking for a whole lot more money this time to buy nothing, something we're conditioned now to expect is free. And like I have no moral like, oh, this is my art. People, should appreciate it to the tune of $75. I am a child of the internet. I grew up expecting things to be free on the internet. I love that, right? I'm standing on the shoulders of giants. I'm standing on the shoulders of telecom engineers and transistor engineers and the dude who's scanning the books at the Library of Congress and putting them on Google, or people on forums. And if I had to bet, I'd guess that it's not a good way. I'm going to try it, because the downside is that if the project isn't fully funded, nobody will have to pay, and I will just go back to selling individual cameras for a lot of money.
You're trying to fund what precisely?
Yeah, so generally, like when I sell a camera, it pays for hours of printer time, which includes materials and electricity, and then it includes assembly time, and then it includes hopefully some premium that pays for however much amount of time I put into designing the initial files and prototyping it. So I went to Spain a couple of months back for almost a month, and I came back and I spent an entire month filling orders, right? And I have at any one point 10 prototypes that are in active development and 40 in a book. And I didn't get any time to work on those things that I'm interested in. I was just making the same camera over and over and over to fill these orders. And I just thought, out of a year, maybe I spend 6 to 8 months of that time spread out over the course of the year filling orders. At least in my mind, the higher value thing that I can do is design these things and print the first 10 of them, make sure they work, and make, if not entertaining, but dry and informative instructional video on how one would print, assemble, and calibrate and use the camera. And so if I could figure out a way to just capture the profit for R&D without doing the manufacturing, that would free me up to do a lot of other things. And probably I'll go to some sort of hybrid model of these things if anything should work out.
And that would sort of bring us back to the idea being that if you got paid ahead of time, in a sense, for your design or knew that you were going to get paid for your design time, your testing time, all of the research that goes into creating this object. If you knew that you could get paid for that time, then you would be happy to give away, in a sense, the results of that.
Yeah, so long as it was a good payout.
Well, we all have to eat. We all have to make
Absolutely.
rent. But you would be just as happy doing that as actually shipping.
I think I would be more happy doing that, right? Like, it's fun to ship a few cameras every week, but it's like I'm sort of measuring my progress by like how many designs I've put out into the world, which I guess I could also measure by how many of those are actually being used by people. But I think giving out the design files would be interesting. I'm not sure how to skin that cat, but I'm working on it, and a lot of people who are smarter than me are working on it. I think a lot of this comes down to everything used to be manufactured in factories with tooling specific to making one thing, right? You might lay out the floor of a quarter-mile-long factory to make all of just the gears in the wind mechanism of one Nikon F. You might have factories and factories of people making these parts and assembling them. I can't/don't want to build up to a huge factory making one thing. And I think the market I'm in is way too niche for such a thing. Also, we're sort of past peak film, way past it, and nobody's really making...
Peak film?
Yeah, when film was like used by the most people or the most number of rolls sold, right?
Until it comes back, the vinyl come back.
Yeah, but it'll come back like vinyl, right? It won't come back in your car.
Right. It'll be it'll have retro cachet. Yeah.
I think nobody's making film cameras, right? What it takes to design a Nikon F is, millions, if not hundreds of millions of dollars worth of R&D and tooling and manufacturing abilities. But cameras are getting old. They're breaking. It's hard to make and find and scavenge parts for them. It's way less this year than it was 10 years ago, and in 10 years or 20 years, right? And so I think, one, it's interesting maybe to put cameras out there that could be repaired, or you could make new parts just by having this file on the cloud if it breaks in 10 years, or you could make a whole new one. And 3D printing technology is only getting better. And so your replacement parts, you wouldn't have to worry, are not as good as originals if they were designed for those sort of strengths and tolerances.
Right.
And I think a 3D printer is medium high tech, but you could buy a totally capable one for $200. I've seen you building your own on the laser cutter downtown, and I think that $200 printer was maybe $3,000-$4,000 or more 10 years ago. You don't need that many tools and that much space and capital investment to build runs of hundreds of thousands of things. You could make a few for niche communities, or a few on your own if you had one of these things, and I think they're becoming more ubiquitous. Yeah, but like getting to that medium scale now, I don't have the economies of scale. When I'm making 200 cameras, it still costs me as much. Once I've paid for the R&D to make one camera and 10 cameras, it doesn't get any cheaper.
Right.
Whereas if I was injection molding things, it would get massively cheaper, but I'd be $2 million in by the time we made the molds.
And committed to having 200,000 cameras in your garage.
Yeah. Yeah, exactly. I don't want to do that.
What's ironic with the coming ubiquity of things like 3D printers is, in some ways, it mirrors actually what happened with photographic printing. I came out of the service bureau world at one point as a designer, and you had to go to a service bureau to get digital prints, whether it was to throw on an offset printing press or to get what we now think of as color photographic prints. You could only go to a service bureau, and it was fabulously expensive to get each print. And now, of course, we've all got, I shouldn't say we all, but many people have photographic quality inkjet printers in their houses that cost...
I bought one for $25.
Yeah, and you pay you pay for the ink. And I think I'm seeing the same thing slowly start to happen with things like 3D printing. I mean, even just 5 or 8 years ago, the only place to really get your hands on some 3D printing was to go to a makerspace where the people there had invested a lot of time, a lot of money into getting a process that worked on the desktop. And now you can have, a really nice printer shipped for like less than $200. And, you might have to fuss with it a little bit, but it's not terribly difficult to get a decent print out of.
I should mention that this is all sort of standing on the shoulders of open source movements as well, right? Another personal hero of mine is Joseph Prasa, right, who runs a giant manufacturer and makes his money manufacturing, but also for years just gave away all of his plans for free, even to businesses who were making knockoffs of his products, which I have some of those,
Yeah.
And somehow made it work extraordinarily well. And I think it's interesting. I don't think bubble jet printers exactly came down in price because people at makerspaces were hacking CD players into bubble jets, but I think 3D printing has been really uniquely driven, like much tech has not, towards cheaper, better things by dudes in their garages.
Yeah, and I think that's just happening more and more. Well, this has been just a great discussion about some issues that are close to my own heart. You're listening to Augmented Humanity. We'll be back in just a minute. Welcome back to Augmented Humanity.
Ethan, today we're talking about how you use modern fabrication techniques to manufacture things from the peak mechanical engineering periods of camera making. And I know that one of the things that you've talked about is that you can't get the same kind of precision. Can you discuss some of the limitations and advantages of 3D printing these cameras and camera parts?
Sure. So every process has its set of limitations. 3D printing allows me to make things cheaply, allows me to make the first one relatively quick, and it allows me to make shapes that are traditionally impossible with subtractive manufacturing, things like routing or milling. It does have its own set of limitations, like plastic is not as strong as metal. The 3D printers that I'm using do not have the same resolution as a very precise watch milling machine, for example. I try and be kind of Bauhaus about working within the limitations of the material. So often I will have a camera with a set of gears or working movements, and I've got to figure out how to achieve precision results without precision parts. And so one of my favorite cameras is a Deerdorf 8x10. It's an old folding wooden camera. It's got a lot of, stainless steel and brass cut parts that fit into wood. And the way they achieve precision movements is they cut very precise gears and they polish them and they put them together very precisely. I can't print a gear that's that smooth or that small or that strong. But what I can do is build two gears and put the spindle or the axle of one gear on some sort of adjustment mechanism so that I can then, after the fact, tension the two gears together so that I can achieve like a smooth movement out of two imprecise pieces. Yeah, you could do something in metal smaller, but any material you use has its inherent pros and cons or advantages and disadvantages for what you're trying to do. And so, yeah, I tend to make big, bulky cameras that are very strong and not as sleek as maybe a metal camera from the 80s.
But they have their own kind of gorgeous aesthetic, if you want to know the truth. There's something about, like you say, if you're playing to the particular medium or the material and it's a strong design, then it will come out looking, in some ways more interesting. You talk about the sleek or highly polished look of the film cameras, at their peak. But in a way, given modern phones, given the crap that we have in our cars, all the modern sleek tech, there's actually something really refreshing about, like you say, you say it's big and bulky, but there's something kind of cool and different about that, I think anyway.
I agree. I think good design always sort of takes advantage of the materials that you're using.
Treat it as your strength and not the weakness.
So I'm curious, earlier we were talking about if you walked into a Nikon factory, how you would have all these different machines doing different things and creating different parts.
I would love to walk into a Nikon factory.
Well, do you use the same materials for all your parts that you print?
So I try really hard not to carry inventory of parts, and I try really hard not to use things that are sort of off-the-shelf precursors that are complicated to cameras. So right now I'm using a lot of like lenses and shutters that are sourced from eBay. It's really hard for me to open a lens factory, although I'm working on it. But for the most part, if I can 3D print it, I will, unless there's a really good reason not to. So on my first camera design, I even 3D printed the screws and the nuts, right? Just to see if I could. Later on, okay, I try now and
you got over it.
Yeah. Yeah. Well, so now I use exclusively M3 hex screws if I can get away with it. And so, my cameras, you can assemble and disassemble entirely with one Allen key. I've actually designed all of the spring movements of the film counter and the door lock on the last camera that I made to take one Bic pen spring cut in half. Just really trying to make it such that I don't have to source and carry inventory of parts. I made a light meter a while ago, and it used 15 different parts. Some were surface mount, some were through hole. A lot of them came from China. Like, it's hard keeping
the electronics you're talking about, right?
Yeah. And it's just sort of hard being stock in parts like that. I try as much as I can to make things out of, one or two materials. Sometimes I laser cut things like dials. The laser cutter is really nice.
What I'm learning today as a camera is a black box that only lets light in a very controlled way. So can you engineer it to be dark inside?
Absolutely. Yeah. I can engineer boxes to be dark inside. That is my best engineering skill in many different ways, right? There's, a lot of plastics will actually sort of glow in light. They're not totally opaque. And so their thicknesses and colors of plastic, you'll notice a lot of my cameras have black bodies. That's for a reason, so I don't have to spray paint the inside so that they're totally light tight. But then there's also interfaces between those black body pieces and colored spring backs and focusing rings and lens locks and things like that. And whenever there's one of those interfaces, you have the ability to let in light. And so sometimes I will use foam and sometimes I will just use interlocking baffled pieces. So like on the door of this panoramic camera, there's no foam on the light seal. It just has, a finger that goes all the way around into a track, and light can't, make 7 180-degree turns to get through it. The homunculus does not use a foam seal. The panoramic does use a foam seal, and there's some reasons around use as to why. But yeah, there are a lot of ways to skin a cat. You don't have to use foam to seal things for light seals for sure, but it helps sometimes.
Something I was thinking about when you were talking about using very few parts and using the parts you're not manufacturing yourself and using parts that aren't difficult to source, the irony is you're started on a lot of this because you can't get parts for old cameras.
For sure.
And it's almost like you're thinking about not dead-ending in your own process of doing this. But, the idea that you'd be able to get 3mm screws or 1/8-inch diameter screws is highly likely.
Yes.
It's not like a special thing. And I think it's really interesting how you seem to be making an effort to not fall into the trap that your beloved cameras fell into to begin with. With that in mind, the optics are not something you're going to make, presumably, unless you start grinding your own lenses. But you said you're sourcing most of those on eBay?
There's a couple of things there. It's not just not having inventory of lots of pieces, but it's not having inventory of lots of tools, right? And so if I can make something 99% on this one $200 tool that I happen to have 10 of, I don't have to have a workshop full of tools. Now, I'm a member of the makerspace downtown, and we have some amazing tools. The laser cutter being my favorite. I don't have one in my shop. I don't have the space for the ventilation. They're big and expensive and heavy. But yeah, designing for one tool is almost more important to me than designing for only one precursor, one input to the process. The other thing you were asking about is lenses. Lens manufacturing is hard, right? So I think there's actually some really interesting advancements in 3D printing technology around injection molding and resin printing that will start to allow us to make really interesting lenses. We have programs like ZMax. It's a CAD software, but for lens design. So, they make, let's say, Eagle or KiCad for PCB design, and they make SolidWorks and Fusion 360 for mechanical design. So they make ZMax for optical design, right? And you can read old patents for optical designs of beautiful modern lenses that are well expired. But the problem is they all not only use curvature of lenses, but also variable indices of refraction, which is sort of, you could think of it as the optical density of glass, even though that's not exactly it, but it's how much one type of glass bends light. And so while you can know exactly how to build, a double Gauss lens, which is like a really common lens in a lot of cameras, really beautiful lens, you can know sort of how it's working and what it's doing, but you might not know how to manufacture that, right? So if I could just, snap my fingers and my glass making machine would make me any shape and any density that I want, cool. I don't have that yet. I think Formlabs and Stratasys are getting pretty darn close. I think some of the optical resins for the fiber optic industry or even the dental industry are like getting pretty darn close. And I think we're going to see a little bit of a revolution in there. But right now, to make glass, you pour a bunch of metals and silica together and you mix them up, and then you pour them out into the molds under incredibly controlled industrial conditions, and then you grind and polish
right.
on huge machines built specifically for that one lens curvature or, a few. For me to build even one element, we're now talking like thousands of square feet just to make one thing, right? And so I don't think people at my scale, right, medium and small size makers are ever going to open a glass foundry and start making elements. However, maybe they will start making some resin lenses. Maybe they'll start grinding and polishing like polycarbonate lenses that are actually pretty decent for eyeglasses that are super available. It's almost like a natural occurring fiber in nature is polycarbonate eyeglasses. There's billions of them on the planet, and some of them are pretty high quality. But, for now, I think you can still buy a lot of optical elements from China for not very much money, and there are certain lens designs that are not quite modern optics, but pretty close, pretty faithful optics that rely on symmetrical designs, which is interesting because you can buy singlets and doublets and sometimes triples online, and you just buy two and reverse them and point them at each other, and then all of a sudden you start having symmetrical lens designs that correct for aberrations.
I get it. Okay. And so that's where you put the same lenses reverse of each other?
Yeah. If you were to flip the lens around, the side that's facing the film versus the side that's facing the subject, it wouldn't matter, right? And so you start getting asymmetrical lens designs, more modern computer-calculated designs that have the manufacturing ability, but before calculus, people did not get very far at all. Once they had calculus, but before computers, they got a little bit farther, but not so crazy. Because of the nature of their reliance on symmetry, if you were to buy some wacky lens group, so long as you buy two of them, you can generally make, at least for large format, like a sort of reliable lens. It's something I'm working on right now. I think as I'm trying to put out like a self-developing back for 20 by 24, and then I can build on the laser cutter some, really big 20 by 24 cameras that are not super expensive. The one barrier for people using this at home, right, under a couple $100, maybe $1,000 even, is buying a lens, right? Right now you have to go find a process lens that would cover such a huge piece of film. Right. I have one. It's an 8-pound piece of glass. It's they get expensive.
Yeah.
But I think it's one of my many projects that I'm working on.
That's really cool. In fact, I actually want to leave this segment with the idea of repurposing old eyeglasses. I just love that idea because...
Okay, to be fair, though, I didn't really mean like a recycling old eyeglasses because they're very cheap and like regrinding old eyeglasses would be more like there's
a lot of work, right?
Yeah. In fact, that's something like there's a lot of scavenged materials that I sort of disregard in my business because I need repeatability to be able to either make a lot of them or have a lot of people make them. My friend Dennis the other day was, hey, do you want these old lenses? You could take the pieces out and make some new lenses. And I said, I have old lenses I haven't taken apart too. The reason I want to do this is I can never buy another third zoom element from a Tamron 28 to 70 from 1986. I can make 3 of them if I buy every stock on eBay, but it would be nice if I was like a little bit more recycle-y, but for now I use a lot of brand new things.
I hadn't even thought about we still have all this stuff that is just floating around waiting for someone to find that new purpose for it. In fact, with you and your whole community trading the old stuff around, the old camera parts around on eBay, I still think is good because otherwise it's just going to go landfill-y anyway. I mean, it's like you said, $1,000 lens from some decades ago probably can be had for pennies on the dollar now, I would presume.
Absolutely.
Well, this has been just a really interesting discussion. Thanks for being with us today, Ethan.
Thanks for joining us.
Thanks so much for having me, guys.
For more about Ethan Moses and his work, visit Cameradactyl.com. Augmented Humanity is a program of the New Mexico Humanities Council, produced in partnership with KUNM-FM. You can visit us online and find out more about our programs at nmhumanities.org. Our theme music is courtesy James Whiten, and we've had production assistance from Tristan Klum.